Welcome to the video. So trying to understand percentiles. When you are learning statistics, at some point, hopefully you're going to run into these percentiles. Now, I'll give you a little bit of a background with regards to the percentiles. I've presented here a data set. So it has 24 data points. And we're going to be working with this and trying to break this percentiles down, and I'll give you numerous hints along the way. Now, if you go a little bit back, you had studied mean, median, mode. Okay, I'll put up a link up above there. Median is definitely useful. Now, what was median? Median basically was the point in the data set which divided the data set where you have 50% of the data on the left of the median and then 50% of the data on the right of the median. And you know that if you have an even number of data points, okay, it would kind of fall in between the two middle points. And if you had an odd number of data points, it would fall on exactly the middle point. Now, that median was actually the 50th percentile. So percentiles are dividing the entire data set, okay, into almost like 100 different types, okay, of intervals, where the first percentile would be taken up by 1% of the data points that lie, okay. Second percentile would mean that you have 2% to the left, okay, and then 98% still to the right, and so on. So it's not very relevant in terms of percentiles that you might want to use it on very small data sets, okay? So even something like this where there's 24, most of the time percentiles will be used when you are in the hundreds, or most likely even in the thousands or 10,000s or millions, where those percentiles can divide the data set, okay? And then you can, talk about, the 80th percentile. We have 80% on the left of it, okay? So that's where you would fall, okay? So that means if you're in the 80th percentile, you're better, okay, than about 80%, okay, of the population within whatever it is. Let's say maybe it's test scores, okay? If someone says you were in the 90th percentile, that means, okay, that you are falling in that 90th interval, and 90% of the students, okay, scored less than you. And if you are in sports, the same thing. If you're lucky enough and you say you're in the 99th percentile, that means you're basically in the top 1%, okay, of those athletes, and then you're better than about 99% of the athletes. So that is, in short, where percentiles are. Calculating them sometimes is a little bit tricky, in particular when it comes to smaller data sets. So there isn't actually a complete unique way to define these, because you will see that if you want to know, okay, kind of strange data sets, and you have small data, the number of data points, then when you're trying to separate things, okay, things are going to get a little bit kind of queasy in a sense, and I'll try to show you and explain that to you. So again, okay, if we're thinking of percentiles, all right, so I have here, it's not necessarily a number line, it's just a collection of data, and I'm going to take a step back and say that, okay, so if you were, okay, right here, and this is, okay, the 50th percentile, that is also known, or better known, as the median, right? Now, in order to find the median, what we would do is we would have all our data points, and then we would find the position, right? So the position itself was equal to, so we would just simply say n plus 1, so where n is the number of data points, okay, divided by 2. Now, this is the same thing as saying that you are, because dividing by 2 is like taking 50%, okay, and then multiplying it by n plus 1. So now we're adding the 1, okay, just so that we can find out where our position is. So for instance here, because we have 24 data points, if we would do this, okay, so 24 plus the 1 is 25 divided by 2, or 50% of 25 is going to be 12.5. And that means that the 50th percentile, or the median, just simply falls between the 12th and the 13th data point. The 0.5 right here actually designates that it's 50% between those 2 points. So it's evenly distributed in between. So it was very easy for us to calculate the median. If it's odd, so if we had 25 points or 25 data points and then we added 1, it would be 26. We would divide by 2, we get 13. So we know that it was exactly the 13th data point that was in the middle. And then on the left-hand side, it would have approximately 50%. And on the right-hand side, it would have 50%. That was the boundary point, okay? So this is the 50th percentile that we would have. Now, when we have percentiles, we're actually referring to the boundary in between there, okay? But a lot of people think in terms of 50th percentile, it means the 50th, all right, interval that you have, okay, within. And I'll come back to that in just a moment. So now the next thing, okay, after studying the median, right, I also did, okay, a video on quartiles. So quartiles, okay, divided our data set into 4 quarters. Median divided it into 2 halves. Quartiles divided it into 4 quarters. So that video on quartiles, I'll put up a link up above there. It's worth watching beforehand. So here what we had was, okay, so we had divided it now into 4 quarters. Okay, so I'm not saying that this is exactly the same, but now you can think about this. The quarters is basically the 25th percentile, and this would have been your 75th percentile. Or as you know, this was, the first quartile boundary. This was the second quartile boundary, and this was the third quartile boundary, and this was quartile boundary number 4, which is your last one that we would have. And we would have within here, so the intervals, sometimes we also would refer to this as this was your first quartile, okay, as well. And it just simply means that this is the first interval in the quarter, where approximately 25%, okay, of the data fall in. Now I say approximately because it will depend on that boundary point. Sometimes it's exactly 25%, sometimes maybe a little bit less, a little bit more. So that's what we have in here. And then each interval was about 25%. And then from those, we could do our box and whisker plot, for instance. That's again in that video link if you wanted to watch. So I'm trying to tie in median and quartiles to percentiles. So as you can see, we can divide it, median divides it in half, quartiles divided in each quarter. And now if you have, okay, something like percentiles, so now percentiles, okay, so how it divides it. Now I'm not going to do all of them, so maybe I'll do something like this where it breaks off and then goes on, okay, right here, okay. So we would have it into 100 intervals. So let's say this was, your first, okay, or 1 percentile. So that means that this is your boundary, okay, so that's your first percentile that you would have. And you would have 1%, okay, lying to this side, and then 99% lying towards this side, okay, of the data points, all right? So we're interested in the data points, not the data values. The values are different, okay? The values might be captured, sometimes we'll do averages or something like that. Here we're just interested in the number of data points. So here if you would say, okay, so now you are in, okay, your second, so, 2 percentile. So that 2 percentile, okay, again would mean that to the left of it, you have 2% of the data points. To the right of it, okay, you have 98% data points. So in general, the kth percentile, all right, so for that, so what it means is that we have k percent, all right, okay, so this is, we have it less, okay, than the kth percentile. Notice that it is less or equal to, so that equal to there. And then you have 100, okay, percent minus k percent, okay, lying, so this would be greater than the kth percentile. So that's exactly what I was just explaining there within. So yes, that boundary point, can include both. So now, if you were doing the calculations for these, they're not actually unique. Okay, it will depend on the number of data sets. Sometimes you might get lucky. Finding the median, this calculation for the median is unique. Okay, finding the quartiles, those boundaries, actually also may not be unique. In the video that I did, okay, I divided and I took the median, found it, and then took just the first half of data set and then found the median of the first half. That's how I calculated that quartile. But it can be done in other ways. And this, okay, is where I actually like, okay, to utilize this kind of approach. So I'm going to duplicate this and bring it down here for myself. I'm going to change the color so that it pops out for you. Okay, and now with regards to this was for finding the median position, right? But in general, sometimes we refer to this as the rank. And then the rank, okay, is the percent, okay, so this is the kth percent of whatever percentile you're looking at multiplied by n plus 1. So now when it's the median, that was 50th percentile, right? Because it was the middle. But what if it is something else? Okay, and what this finds you the actual rank or the position, right? That's why it was called the position. So this you can call position or rank. Okay, at least that's what I refer to it as. Okay, it will depend on the teacher. So that position just tells you, okay, which point are you going to be choosing? So again, if I take this entire data point set, so I'm going to take all of this right here, and let's try to calculate and understand these percentiles with regards to that. So I'm going to paste this up in here. So the easiest one to know, right, was 50th percentile. So the 50th percentile, all right, let me find my position, okay, or my rank. So this would be 50% or 0.5, 24 plus 1. So as I mentioned to you, so within that, you would get this is 25, this is 12.5. So now I am going to be counting up, so I need the 12 and then the 13th value, and I am going to be calculating the midpoint because 0.5 in between them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so this is 3 plus 3, this is 13th point, and I divide by 2, or I take 50%, which clearly just means, okay, the 50th percentile would be just simply equal to 3. That's the boundary. And from 3, right, to the left, there's about 50% of the data points, and then to the right, there's 50% of the data points. Now here is where the percentiles, okay, and the calculation for them may not always align, okay, and I'll notice in terms of, I'm going to go back to quartiles. So how did I calculate quartiles? In the video, what I did was I took, all right, so let's take the half of the data points. Now in this case, that's 12, because that's exactly because I had an even number, right? So there's 12 of them there. So that means quartile, the first quartile, or the 25th percent, you know, I could say, all right, well, I have 12 in the first half. And I can again play this position game. And I can say 12 plus 1, which is 13, divided by 2 is 6.5. And 6.5 would mean I'm going to take the 6th and the 7th, and then I'm going to divide by 2 to find my boundary for my quartile in between. That is fine. You can define it that way for quartiles. All right? And you'll get kind of always the unique answer. But if you're thinking about percentiles and now you're taking the 25th, notice what happens here. What will happen here, my position or my rank is equal to, so 25% is 0.25. Now this is the total data set point, which is 24 plus 1. And within here, so 24 plus 1 is 25. And if I'm not correct, if I'm not mistaken, I think the answer is going to be 6.25. So times 25. Indeed, it's 6.25. And notice that is the rank or the position that I'm looking for. And it's not 6.5 as I had if I only took half of the data, okay, and then found that quartile, first quartile number. 6.25, well, that's interesting. What that is telling me that I'm going to take 6th data point and the 7th data point, and this value of the fraction, okay, is basically 25%, okay, between these 2 points. So it's not at the half, okay, it would be about here, which is 25% in. Now I have to know and I have to find out what was my 6th value, what is my 7th value. So I would go in here, so my 6th value, so that's 1, 2, 3, 4, 5, 6. So 6 was 1, okay, so that's 6, and 7 was 2. All right. And now, okay, so in between here, so in between these two, so obviously 2 minus 1 between those 2 data points. Okay, so that is just equal to 1. So that's the distance between 1 and 2. And now if I take 25% of that, well, that's simply just 0.25. So what I do is I take, all right, well, 0.25. So that means that this boundary point of the 25th percentile is 1.25. And notice that is different if you would take quartiles and you would say, oh, there are 12 data points in the first half. Okay, if I want to take the median from that 12, my answer is going to be for the position or the rank is going to be 6.5, which actually would mean that would fall in the middle. And instead of writing 1.25, you would have 1.5. That would have been your first quartile, and this is your 25th percentile. So which one is right? Well, both of them are. It depends how you choose to define these things. And this is what the subtle things that you start noticing when you do take probability and statistics, so data management, right? Kind of probably in high school at some point and then later on in university. Anyone who's kind of like me, where you have studied math and you continuously have found that you find these steps and it's very unique in terms of your answers, that sometimes will fall apart. So when I say it falls apart, because it will depend on how you define, right, your calculation. So this is how I would calculate it, okay, within. So if someone told me about percentiles, then I do it by here, by the rank or position, okay, and I have to do a little bit of work, okay, to find it. And if you're doing quartiles, sure, you can certainly do that, but please ensure, to just pay attention to the teacher that you have. What do they want? Sometimes, people will just, I'm not saying it's lazy because it's not unique. So they said, why am I going to be calculating these things so closely? What they might say for the 25th percentile, they might say, all right, well, my answer is 6.25. I'm going to just round it. So rounding it is 6, right? And then they might just take the 6th data point. Okay, or they might say, okay, let me round it and then add 1 to it. So it would have been 6 plus 1, which is the 7th data point. Okay, or something else. So there's different ways of defining this, and that will frustrate you. Okay, and that's okay. Just make sure to think about, all right, what am I going to choose, and then be consistent. So I like doing the calculations. Okay, so this is what I do. All right, so let's calculate something else. I want to give you another example within here, okay, just so that we can see the process. So the process that I do for a calculation is first find the rank, okay, or also known as the position, which just means whatever percent you want multiplied by the number of data sets that you have plus 1. That will give you the position. Then you will locate. Now, if you get lucky, if it's an integer, then you already have your percentile boundary. But if it's not an integer, if it's a decimal, then unfortunately you're going to take the 2 data points between the integer value, so the whole value and the next value. And then by percent, the fraction that you get will allocate, okay, the data point. So I'm going to pick something silly here. Okay, so out of these data points, let me pick, okay, it doesn't make sense because we have 24 data points, but I think it's going to show you the calculation so at least you can understand it. So let's say I wanted the 95th percentile to find the boundary in between, okay? So for this, what I would do is I would say, all right, so 95, 0.95, I have 24 points plus 1, right? So that's 25. It's going to give me, let's see, 0.95 times 25. Okay, this is 23.75. All right. Now, that shouldn't surprise you because we have so little data points. So now, so what here is I need the 23rd data point and the 24th data point, right? So those are the 2 data points that I need, okay? Now, what are those 2 data points? Well, those are the 2 last values. So that's the 9 and the 15. So I'm going to put here, all right, because now you want to know the value of the 23rd. So the value of it was 9 and the value of the 24th was 15. All right, so now where's the boundary? Well, okay, so here it tells me that the boundary is 0.75. Well, 0.75 in between here, so that means, okay, it's 75%, okay, of the bit in between them. So that's what we have to find. So what is that? Well, you will take 15, so the data point, the data value minus this, so that is 6. So that length is 6, and you're taking 75% of 6. All right, so within that, that's going to be 4.5, 75%. And now you say, all right, well, 9 plus 4.5, so in this case, is going to be 13.5. And that becomes your boundary point to the 95th percentile. Okay? So those are the calculations and hopefully understanding percentiles. Again, it will depend. Sometimes your teacher might define these differently, but the ultimate goal is to try to understand and think, okay, if someone says you're in the 80th percentile, okay, that means that, you are better, okay, better. I mean, you maybe scored on that test, okay, better than 80% of the people that are there. So you're in the top 20%. Okay, if someone says you're in the 99th percentile, that just means that you are in the top 1%, okay, and you've scored better, okay, than 99% of the people, right? Those boundary points, okay, sometimes you might define them a little bit differently, but they won't really matter that much, especially when you do have a huge data set, number of data points, right? So data, sometimes for national scores, you have tens of thousands of students, right? Or athletes, again, you have quite a lot of them. If you have a smaller data set, percentiles, not really that useful. Probably it's better to just talk about quartiles, all right? This video just wanted to show you how these percentiles can be calculated. All right, so I'm going to stop here. I hope that you found this useful, and we'll see you in a future video, okay? Bye, stats guys.